Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 10 students and the topic of discussion is some applications of trigonometry. This is the second video on applications of trigonometry. In the first video, we discussed or defined angle of elevation and angle of depression. We also solved few practical problems in that video. The link of that video is given in the description box of this particular video. In this particular video, we give extra punch problems or the hot questions which are examination based. So pay attention here students and be ready with pen and paper. Let us understand the first problem first. A tree breakdowns and the broken part bends so that the top of the tree touches the ground, making an angle 30 degree with it. So a tree was there and it has broken down at point A and now it is touching at point C on the ground. So this particular angle is 30 degree given. The distance between the foot of the tree to the point where the top touches the ground is 8 meters. So from the foot of the tree to the point where it touches the ground is 8 meters. We need to find the height of the tree. So what is the height of the tree now? Height of the tree originally was BA plus AC. So we need to find both these lengths and then we will add them up to get the original height of the tree. This being a triangle, ABC being a triangle with right angle at B, we can use trigonometric angles definition to get AB and AC. So let us in triangle ABC cos 30. Cos 30 is BC by AC. That is adjacent side by hypotenuse. BC is given as 8 and AC is given as to be defined. And 8 by AC will be root 3 by 2. Cos 30 is root 3 by 2. On cross multiplying we will get AC as 16 by root 3. Now let us try to get AB now. AB by BC is tan 30. AB by BC is tan 30 which is 1 by root 3. Again we want to get AB. So AB and BC is already 8 meters. So AB is 8 by root 3. AB is 8 by root 3. Now height of tree is AB plus AC which is 8 by root 3 plus 16 by root 3. This is 24 by root 3. We multiply root 3 on both sides. So denominator root 3 into root 3 will be 3. 24 divided by 3 will be 8 and numerator root 3 will be there. So the height of the tree is 8 root 3 meters. In the examination, please do not draw the tree. This is just for illustration. You need to just draw the triangle showing the total tree. You can just mention AB plus AC will be tree length. That is enough. In this problem, from a point 50 meter above the ground, the angle of elevation of a cloud is 30 degree and the angle of depression of its reflection in water is 60 degree. Find the height of the cloud above the ground. So from a point 50 meter above the ground, let us take that point be A. So it is looking at the cloud with an elevation of 30 degree. And it is angle of depression on the reflection. Its reflection is on the ground at point C. So that angle of depression is 60 degree. And this point A is 50 meter above the ground. So BC will be 50 meter. We want to find the height of the cloud. Let the height of the cloud be x meter from ground. So how do we approach this particular? How do we estimate x? We observe that there are two triangles and we assume that the distance AB is y, which is unknown. We observe that there are two triangles ADB and ABC where we can apply trigonometric principles. And what we will do, we will first use this triangle and get y. And similarly we will use this triangle and again try to get y. Then equate both y's and get then the unknown x. So let us proceed. with in triangle ABD. In triangle ABD, tan 30. Tan 30 is opposite side by adjacent side. BD by AB. What is BD? Full is x meter from the ground, and this particular point BC, we know it is 50 meter. So BD will be x minus 50 divided by y is tan 30. What is tan 30? Tan 30 is 1 over root 3. So from this we will just bring y into picture. So y will be root 3 into x minus 50. This is our first equation. So similarly in this triangle also we will bring out y, and then we will equate these two. So let us see in triangle ABC, what is tan 60? Tan 60 is opposite side by adjacent side, which is BC by AB, which is 50. This is 50, BC is 50, and this is y. So 50 by y. And what is tan 60 is root 3. So cross multiplying will give y equal to 50 by root 3. Now these two expressions we will equate and get the unknown x. So 50 by root 3 equal to root 3 into x minus 50. Root 3 will take it on the numerator on RHS. So this will be 50 equal to 3 into x minus 50. So 3x minus 150. So minus 150 will come here 200. So x will be 200 by 3. So this will be the height of the cloud above the ground in meters. This is bit challenging problem, so pay attention here. In this problem, at the foot of a mountain, the elevation of its summit is 45 degrees. Summit means peak of the mountain. Peak of the mountain is at B. So if you are at the foot of the mountain, you see that the elevation is 45 degrees. So it means angle BAC. Angle BAC is 45 degrees. After ascending 2 km towards the mountain, so from A we ascend 2 km with the slope of 30 degree. So angle PAC will be 30 degree. Inclination, the elevation is found to be 60 degrees. So this angle from here, after climbing here, we find the elevation as 60 degree. So we need to find the height of the mountain. So how do we proceed? We see that there are three triangles now. One is BPD, where we can apply the trigonometric principle. Another is PAC. Another is BAO. So these three triangles will be applying trigonometric principles. First we will start with PAC, because already one length is given and one angle is given. So we will apply the trigonometric principles here. So in triangle APC, what is sine 30? Sine 30 is opposite side by hypotenuse. So PC by AP. PC by AP. AP is 2 km given here. So PC by 2. And what is sine 30? Sine 30 is half. So 2 can get cancelled in the denominator. So PC will be 1. So PC is 1. From observation, we also note that PC is equal to OD. So if PC is 1, OD is also 1. This is equation 1. Now we see triangle APC again and compute AC now. So we observe that cos 30 is AC by PC. AC by AP. Cos 30 is AP by AP. So what is AP? AP is 2. What is cos 30 is root 3 by 2. So we will get AC as root 3. This is our second equation. So we already got AC, we also got PC. Now we consider triangle ABO, the bigger one. So that is tan 45. So tan 45 is BO by OA. So which is H by OA, and tan 45 is 1. So H is equal to OA, or OA is equal to H. OA equal to H. Now we consider this small triangle BPD. So what is, friends, BD? BD is H minus OD. What is OD? 1. So BD is H minus 1. What is PD? Or PD is equal to OC. So what is OC? OC is equal to OA minus AC. So what is OA is H and AC is root 3. So this distance will be H minus root 3. This distance will be H minus root 3. PD will be H minus root 3. So now we take this triangle, tan 60 will be BD by PD, which is H minus 1 by H minus root 3. And what is tan 60 is root 3. So this particular thing will be simplifying with respect to H. So H minus 1 root 3H minus 3. Simplifying this will give H as root 3 plus 1. So what is root 3? Root 3 is 1.732. 1.732 plus 1 equal to 2.732. This will be the height of the mountain in kilometers. Let us take a simpler problem. In this, an observer 1.7 meter tall is 20 root 3 meter away from a tower. Let the tower be CD. Observer is 20 root 3 meter away from here and he is standing at point B. The angle of elevation from the eye of the observer. So he is 1.7 meter tall. So from point A, he will be observing the tower D with an angle of elevation of 30 degrees. So this is 30 degree. 30 degrees is not measured from the bottom, but it is measured from a height of 1.7 meter. This is very important. Now we wish to find the H, the height of the tower. In this triangle ADE, we can apply this. This particular distance is known. We can get this distance is H minus D is H minus 1.7. So H minus 1.7 divided by 20 root 3 is tan 30. Tan 30 is 1 over root 3. Root 3 are in denominator, they will get cancelled. Then we cross multiply. H minus 1.7 will be 20. So H will be 20 plus 1.7, which is 21.7 meter. This problem again is very interesting and challenging. Let us discuss this problem. A bird is sitting on the top of a 80 meter high tree. From a point on the ground, the angle of elevation of the bird is 45 degree. Let the bird be sitting on this tree BC, which is at a height of 80 meter, and the angle of elevation of this point C from ground is 45 degree. This is given. So angle CAB is 45 degree. Now the bird flies horizontally in such a way that it remained at a constant height from the ground. So let us assume that the bird is flying in the right side, then it moves to point A horizontally. Then after 2 seconds, the angle of elevation of the bird from the same point is 30 degree. Now let us assume in 2 seconds, the bird has traveled a distance x and the new point, the angle of elevation is 30 degree. This is 30 degree. It means angle EAD is 30 degree. We need to find the speed of the flying of the bird. So we need to find what is the speed. So speed of the bird is distance covered by time taken. Time taken is 2 seconds and the distance covered is x to be found out. So once we get x, we will divide x by 2. We will get the speed in meter per second. So how do we get x now? So first we consider this triangle CBA, this particular right angle at B. So we will see tan 45 is CB by AB. CB is 80 by AB. What is tan 45 is 1. So AB is 80. So we get this distance as 80. Let us take this bigger triangle now. So what will be tan 30 here? Tan 30 will be DE by AD. This is 80. This is 80 plus x because AB is already 80 we evaluate. So this is 80 plus x. So we have written 80 by 80 plus x. Tan 30 is 1 over root 3. So we cross multiply. So 80 plus x will be 80 root 3. So x will be 80 root 3 minus 1. This is the distance BD or the distance CE. Now speed is distance by time. So distance is 80 into root 3 minus 1. Time already given as 2 seconds. So this will be divided by 2. So what is the value of root 3? Root 3 is 1.732. On substituting, we can get speed as 29.3 meter per second. This is the speed of the bird. In your examination, sometimes instead of giving numerical values, you may be asked to solve the problem with analytical values. For example, here no data is given in terms of like 30 degree or 40 degree or some distances. Instead, you are given angles like alpha, beta and the distance p. So you may have to solve this or get this analytical expression in the examination. This is also very interesting. Let us solve this problem. The angle of elevation of the top of a tower from a point on the same level as the foot of the tower is alpha. So from B, we see the top of the tower angle as alpha. On advancing p meter towards the foot of the tower, p meter towards moving towards C, the angle of elevation becomes beta. Show that height of the tower is given by this particular expression h. P tan alpha tan beta divided by tan beta minus tan alpha. So let us consider first the bigger triangle ABD. So we know that tan alpha is AD by BD. What is BD is BC plus CD. So this is equal to H by BC plus CD. What is BC? BC is given as P equal to P plus CD. H by P plus CD. Now we want to get CD. CD we will get from the other triangle. From other triangle tan beta is H by CD. Tan beta is H by CD. So CD is H by tan beta. Cross multiplying CD will be H by tan beta. So we will substitute here the value of CD as H by tan beta. So tan alpha is equal to H by P plus H by tan beta. Solving this we get H as P tan alpha tan beta divided by tan beta minus tan alpha. So we got the analytical expression which we required and hence proved it. In this particular problem, the angle of elevation of the top of a tower from 2 points distance x and y from its foot are complementary. Complementary means if one angle is alpha, the other angle will be 90 minus alpha. Means sum of these two angles will be 90 degree. That is complementary angles. Sum of two angles is 90 degree. So if this is alpha, this will be 90 minus alpha. That's what given in the problem. We need to find the height of the tower is square root xy. So let us assume DC is x and DB is y. So we will again consider the bigger triangle first. So tan alpha will be h by y. Tan alpha will be hy, opposite side by adjacent side. In the smaller triangle ACD, tan of 90 minus alpha will be h by x. Tan 90 minus alpha is h by x. What is tan 90 minus alpha is cot alpha. So let us multiply these two expressions. So tan alpha into cot alpha is equal to h by y into h by x. But what is tan alpha cot alpha? Cot alpha is 1 over tan alpha. So tan alpha into 1 over tan alpha will get cancelled. So we will be remaining with 1. So we get the expression now h by y equal into h by x is equal to 1. So this will be h square. So h square will be xy. Now taking square root on both sides we will get h equal to square root xy. That's what we wanted to prove. That is height of the tower is square root of xy. With this we conclude this particular video. I request you friends to please subscribe my channel and give a thumbs up to this particular video. Thank you very much friends.